Okay guys, this is our second lecture and today we're gonna start with events, sets and set operations. An event is just a set, so relationships and results from elementary set theory can be used to study events. The following operations will be used to create new events from given events. Okay, the first one is the complement of an event A denoted by A prime is the set of all outcomes in S that are not contained in A. I mean, A prime is the set of all outcomes in S that are not contained in A. Complement is the set theoretic difference of S and A. That is, then A prime is gonna be S minus A. Like, what I mean, we have a space called S and we have a set called A, and A prime is not gonna contain elements in the A, but it will contain the elements S minus A. Okay, the second one is the union. I will talk about union. The union of two events A and B denoted by A union B, and we will read it A or B, is the event consisting of all outcomes that are either in A or in B, or both events, so that the union includes outcomes for which both A and B occur as well as outcomes for which exactly one occurs. That is all outcomes in at least one of events, because let's say A is like 1, 2, 3, and B set is gonna be like 3, 2, 5. And then A union B is going to be 1, 2, 3, 5. Okay, this is our union. The last one is intersection. The intersection of two elements A and B denoted by A intersect B, and we read it A and B, is the event of consisting of all outcomes that are in both A and B. And let's say again A is 1, 2, and 3, and B is gonna be 2, 3, 2, 3, 5, and A and B is gonna be equal to, they both must contain these things, these numbers, and that's gonna be like 2 and 3. Okay, this is our intersection. And now we're gonna go on with what is mutually exclusive or disjoint events. Okay, if we talk about it, let that one denote the null event. Okay, this symbol is gonna denote the null event. The event consisting of no outcomes or whatsoever when A and B is null. A and B are said to be mutually exclusive or disjoint events, and this is what we call that one. Okay, and if we give an example about that ones, let's solve the example. For the experiment of tossing of two coins, let's the event to be A is gonna be equal to HT, head and tail, and TH, and E1 is equal to HH, and let's say E4 is equal to TT. Okay, then as we talk it here, let's find the A prime, so equals to what, and let's find A union E1 prime, and let's find A intersection E1 is what. So if we try to solve the questions, first of all, let's know what is our A. Our A is that one, and we need to find our sample space now. Our sample space are like containing all the cases here, okay? All the events here. We already talked about what is sample space, and then I'm not gonna talk about more about it, but if I mention it in a simple way, I should say that it will contain all the events here, okay? So our sample space is going to be HT, TH, HH, TT, right? This is our sample space. And let's find whatever I said to you before. The A prime is gonna be equal to sample space minus A. So our A is that one, and we will just subtract A from space, okay? So do it, let's do it. HT, HT, right? TH, TH. We subtracted them, and now that one is left to us. So that A prime is gonna be equal to A minus S. A prime is gonna be equal to S minus A, and it's gonna be equal to HH and TT. This is our A prime. Now let's find that union. So what is our A? Now we already know the A, and now we should know the A1, and we also know the E1, and we should just make them add each other. So HT, TH, and HH. That's it. But it asks for prime. Then this is prime is gonna be, let's say that X, okay? X prime is gonna be S minus X. So let's just subtract them from the S. What is our S? That one. So just subtract and write. HT, HT, we need to subtract that. TH, TH, we need to subtract that. HH, HH, we need to subtract that. So that just only HH, okay, we subtracted that already. Just only TT is left to us. So our X prime is gonna be equal to TT. That's it. And the last question is A intersection E1. So if we talk about it, what is our A? A is that one, and what is our E1? E1 is that one. They both must contain the same cases, same events if we want to intersect each other. E1 has HH and A has HT and TH, so they have no intersection. So our intersection is gonna be equal to null, which I talked before. Okay. This lecture is enough for now, and I'm gonna continue with Venn diagrams in the next lecture. See you for now. Have a good day.